Let's look at natural numbers and integers, and we'll begin by looking at a subtraction problem. If we have something like 463 minus 418, then the first thing we do is we say 3 take away 8 we can't do. So we have to borrow 1 from the 6, so that turns the 46 into 45, and then we have 13 take away 8 is 5. 5 take away 1 is 4, and then 4 take away 4 is nothing. Our answer is 45. Let's look at a division problem here. So if we have 30 divided into 390, or you might recall this as 390 divided by 30. If we divide 30, let's begin by saying, well, 30 into 3 won't go. 30 into 39 goes once. 1 times 0 is 0, 1 times 3 is 3, or 1 times 30 is 30. 39 minus 30 gives us 9, and we bring down our 0 from here, and we say 30 into 90 goes 3 times, and 3 times 90 is 90. 90 take away 90 gives us 0, and this is where the division problem stops. 30 goes into 390 13 times. And if we now look at multiplication problem, something like 28 times 16, well, we say 8 times 6 is 48, so we write down our 8 and we carry our 4, and we say 8 times 1 is 8 plus the 4 is 12. Put down our 0, 2 times 6 is 12, put down the 2, carry the 1, 2 times 1 is 2 plus 1 is 3, and we add those up. 8 and 0 is 8, 2 and 2 is 4, 1 and 3 is 4. 28 times 16 is 448. So what are natural numbers? Natural numbers are the set of whole positive numbers. 1, 2, 3, 4, all the way up forever and ever to infinity. And the set of natural numbers are denoted by the capital letter N. If we move on to look at squares and roots, we can see that we use this different type of mathematical notation where we have a base number to the power of another number. Okay, and that power, or if it's a 2, it's squared. If it's a 3, that power is known as cubed. And if we write a number as something like 4 to the power of 3, that number is written in what we call its index form, where 4 to the power of 3 is the same as 4 times 4 times 4. Similarly, 3 squared, or 3 to the power of 2, is the same as 3 times 3. 4 squared is the same as 16. 4 fours are 16, or 4 times 4. And I guess looking at it the opposite way then, we have this other symbol in maths, the square root sign, or the root sign, sorry. Generally, if you see no number here, then we take it to be the square root sign, but in higher level maths you'll come to see that you might see the root sign with the 3, and you might have something like the cubed root of 8. The cubed root of 8 would be equal to 2, i.e. 2 times 2 times 2 is equal to 8. The cubed root of 8 would be equal to 2. So back to the square root sign. So the square root of 4 is 2, i.e. that number, when multiplied by itself, gives us 4. The square root of 81 is 9, i.e. that number 9 multiplied by itself would give us 81. And another way of writing to write 9 in its index form equal to 81, 9 squared is 9 to the power 2, or 9 squared is equal to 81. And if we look at next the notion of the lowest common multiple, we can see that the multiples of a number are simply those numbers multiplied by 1, 2, 3, 4, 5, 6, etc. So the multiples of 16 would be 16, 32, 48, 64, 80, and so on. And the multiples of 20 would be 1 times 20, 2 times 20, 3 times 20, 4 times 20, and so on. And in maths we come across the notion of the lowest common multiple, and basically if we're to look for the lowest common multiple of two numbers, say 16 and 20, we simply list the multiples and we look for that multiple that's common to both lists and is the lowest common multiple, and in this list it's 80 and 80. So 80 is the lowest common multiple of 16 and 20. We use the lowest common multiple in the addition and subtraction of fractions, which we'll come to in the next chapter. Also in this chapter we came across the notion of factors or divisors, i.e. Factors being the factors of a number are those numbers which divide evenly into that number. So 1 is a factor of every number, and every number is a factor of itself. A factor of a number divides evenly into that number. Okay, so the factors of 46 are all those numbers that divide evenly into 46. So we can say 1 goes into 46 evenly, 46 times. 2 goes into 46 23 times, and there actually are no other numbers that go into 46 evenly, so these are the 4 factors of 46. If we were to look at the factors of 48, we can see that 1 goes into 48 48 times, 2 goes into 48 24 times, 3 goes into 48 16 times, 4 goes into 48 12 times, and 6 goes into 48 8 times. These are all of the factors of 48. And we also come across in maths, or in this chapter we met with the highest common factor, and basically if we would need to find the highest common factor of 46 and 48, then we simply list the factors and we look for a factor that's common to both lists, and if there's a few factors common to both lists, when we're looking for the highest common factor, we look for the highest factor that's common to both, and in this case it's 2. So the highest common factor of 46 and 48 is equal to 2. We use the highest common factor when we're simplifying fractions to equivalent fractions. For example, if we had something like 12 over 18, to simplify that or reduce it to its simplest form, then we would look for the highest common factor in 12 and 18, and we would divide above and below by that highest common factor. If you were to list the factors of 12 and the factors of 18, you'd find that the highest common factor of 12 and 18 is equal to 6, and to simplify 12 over 18, divide above and below by 6, we would get 2 over 3, and that is an equivalent fraction to 12 over 18, and it's 12 over 18 reduced to its simplest form. We shall meet with this notion in the next chapter. And just another point about finding the factors of a number. If we want to find the factors of a number, the fastest way to find how many times we need to divide numbers into the number, there's a tip or a trick to finding where we stop dividing numbers into find factors. Let's say we want to find the factors of 36. The mathematical trick would be to find the square root of 36, and in this case it's actually equal to 6, and so we'd simply divide all the numbers 1, 2, 3, 4, 5, 6 into 36 to see if we have all the factors, and 1 would go into 36, 36 times, 2 would go into 36 18 times, 3 would go into 36 12 times, 4 would go into 36 9 times, 5 would go into 36, doesn't go evenly, and actually 6 goes into 36 6 times. So these are all the factors of 36. Let's say we wanted to find the factors of 15, then we could look for the square root of 15, and we see that's equal to 3.87 if we were to do that in our calculator. Well, in this case, when we don't get a whole number here, we need to round it up to the nearest whole number, and this is the number we will use when we're dividing up and into 15 to find our factors. In other words, we'll divide 1 into 15, and that will go 15 times. 2 into 15 doesn't go evenly. 3 into 15 goes 5 times. 4 into 15 doesn't go evenly. And we know that we can stop checking once we've tried 1, 2, 3 and 4 into 15. And these are the factors of 15, 1, 3, 5 and 15. Let's look at prime numbers. Well, prime numbers are numbers that are only divisible by itself and 1. And prime numbers basically have two factors only, itself and 1. So a list of the first 7 prime numbers would be 2, 3, 5, 7, 11, 13, 17. These are the first 7 prime numbers, in that only 17 goes into itself evenly and only 1 goes into 17 evenly. Same for 13, 11, 7, 5, 3 and 2. A list of prime numbers. Sometimes we're asked to express a number in terms of its prime factors. So let's express the number 36 in terms of its prime factors. This means that we're basically looking at this list of prime numbers and we're dividing them into 36 to see do they go evenly. So 2 goes into 36 18 times, and 2 goes into 18 9 times. 2, I'm using numbers from this list here, 2 doesn't go into 9 evenly, but 3 goes into 9 3 times, and again 3 from this list goes into 3 once, and when I get to 1 I stop. And these numbers here, if I multiply them together, if I have 2 times 2 times 3 times 3, these are all prime factors of 36. 2 2s are 4, 3 4s are 12, and 3 12s are 36. So I can say that 36 represented as its prime factors is equal to 2 times 2 times 3 times 3, and I could even say that that's the same as 2 squared times 3 squared. Let's represent the number 25 in terms of its prime factors. Well, I look to my list here and I see what prime number can I try and divide evenly into 25, and 5 goes into 25 5 times, 5 goes into 5 goes into 5 once, I'm at 1, so I stop. So I can see that 25 is equal to 5 times 5, or 25 is equal to 5 squared. This is 25 represented as a product of its prime factors. 25 represented as a product of its prime factors is 5 times 5. So let's start by looking at BIMDAS, the order of operations whereby we solve long sums like this by first scanning through left to right and fixing anything that's in brackets. Then once we've done that, scanning through from left to right and fixing anything that's raised to a power or an indices. Then scanning from left to right, fixing anything that anything or any time there's a multiply or division sign, and it's whichever one we hit first from left to right, multiply or division. The multiply and divisor do not have precedence over each other, they're equal. When we've looked at all of those, we then go through the sum and we look for any addition or subtractions, and again we do whichever one, be it addition or subtraction, whichever one we hit first, go from left to right. So here's an example here. 18 divided by 6 plus 2 squared minus, in brackets, 7 plus 2 divided by 3 plus 1 plus 3 times 7. So following BIMDAS, and I've written BIMDAS like this to show that this is first, this is second, it's either or multiply or division, and either or addition and subtraction following that. So first thing we fix is in the brackets, that becomes 9. The next thing we fix is the number that's raised to the power of 2, or the indice. Has an index of 2, and that becomes 4. The next thing we do, scanning from left to right, we see that there's a division sign here, so that becomes 3. And as we scan from left to right again, we see then there's another division sign, and that becomes 3 here. And as we scan from left to right, then we actually find a multiply sign, so we do 3 7s is 21. And then as we scan from left to right, we see a subtraction, so we do that. 7 minus 3 is 4. And then we have 4 plus 1 plus 21, and our answer is 26. Again here we've another example, 4 times 2 minus 1 plus 2, all in brackets, squared by 2 divided by 3. So let's fix the 1 plus 2 in the brackets first, becomes 3. Let's then fix that next, 3 squared becomes 9, following our BI. Then as we scan from left to right, we have a multiply sign, so 4 2's are 8. And we also see that we've 9 by 2 here, so we'll fix that next. We've 8 minus 1 plus 9 by 2 is 18 divided by 3. Now we'll fix the 18 divided by 3 next, because that's one of these. It's a division, which is ahead of addition or subtraction here. It's a division, yes. So we've 8 divided by 3 is 6. So now we have 8 minus 1 plus 6. So we'll do the 8 minus 1 first. We'll get 7 plus 6 is 13. So that's BIMDAS, the order of operations. Let's look at rounding numbers, okay? So when we're rounding numbers to something like 3 significant figures, then we look at the next figure, the fourth figure, and we see if it's what digit it is, or what value it is. If it's 0, 1, 2, 3, or 4, then we will do nothing to the third digit. But if the fourth digit is a 5, a 6, a 7, or 8, or a 9, then we will add 1 or round up, add 1 to the third digit. So for example, 5, 6, 3, 4, 8, round that to 3 significant figures, then we look at this fourth figure and we see what its value is, okay? So the 4 is one of our 0, 1, 2, 3, or 4 value, so that means we leave this alone. We do nothing to this 3, we leave it as is. So 5, 6, 3, 4, 8 rounded to 3 significant figures simply becomes 5, 6, 3, 0, 0. And that is 5, 6, 3, 4, 8 to 3 significant figures. And just to mention the terms associative, what that means. Basically, all associative means that grouping of numbers in brackets or not in brackets, it doesn't matter how we group numbers when we're adding or multiplying them. That's the associative property of addition and multiplication. So 6 plus brackets 8 plus 4, which is 12, is the very same as 6 plus 8 plus 4. Okay, so 12 and 6 is 18, 6 and 8 is 14 plus 4, that's all equal to 18 as well. Okay, and it's the same with multiplication. 2 times 3 is 6, times 1 is 6, or 3 times 1 is 3, times 2 is 6. So whether we have them inside the brackets or outside, for addition and multiplication doesn't matter. It does with division and subtraction. The commutative property in maths tells us that the order of the numbers 8 times 7 is the same as 7 times 8 in multiplication, or the order of numbers in addition 1 plus 2 is the same as 2 plus 1. It doesn't matter. That's what commutative means. Let's look at adding and subtracting integers, the main point here being what we do with the signs. So if we're adding two integers, remember now integers can be positive or negative whole numbers. So if we're adding or subtracting two numbers or adding numbers with signs, we have to be conscious of the signs they have. So if the signs are the same, we keep that same sign and we add the two numbers. Okay. If the signs are different, we keep the sign of the bigger number numerically and we take the small number from the bigger. So, for example, minus 6, minus 3, the sign is the same. What is the sign? It's minus, and we add the numbers. 6 and 3 is 9. If the signs are different, minus 6 plus 3, what's the sign of the bigger number numerically? It's minus. The bigger number of 6 and 3 is 6, and the sign is minus. We keep that sign. We take this small number from the bigger number, and we get minus 3. Now, when we look at multiplying or dividing integers, then we just look at the signs, and like signs, be they both positive in the numbers we're multiplying or both negative, give a positive sign. Unlike signs, i.e. a negative and a positive, or a positive and negative, multiplying or dividing give a negative sign. Okay? So let's look at this example here. Plus 4 multiplied by minus 4. Plus by minus, signs are different, gives us a minus, or the unlike minus sign, and 4 fours is 16. Or in this case here, plus 4 divided by minus 2. Well, a plus you can't see, but it's there. Plus and minus gives minus, and 4 divided by 2 is 2. Here we have minus 2 divided by minus 2. The signs are the same, so that gives a plus here, and 2 divided by 2 is 1. And a very important part of working with integers is when we have an integer, be it a positive or a negative number, inside a bracket, we have to be conscious of what the negative sign does to the number inside the bracket. So if we have minus 4, like we have here, then that gives us plus 4. Why is that? That is because the minus actually has a 1 beside it that you cannot see, but it is there. Minus by minus gives plus, 1 by 4 gives 4. Look here, we have 2 in brackets. What's outside the 2? Well, there's a plus 1. It's there, but you can't see it. So plus by plus 2 gives us plus, and 1 by 2 gives us 2. And if we look at this example here, we have minus 2, minus brackets 2. What's that equal to? Well, that's the same as minus 1 by plus 2. So minus by plus is minus, and 1 by 2 is 2. So in effect, a sign or a minus sign outside the brackets changes the sign of the inside number. So if we have minus 4 becomes plus 4. This seems to change the sign of the number inside the brackets, and that's a very important rule in mathematics.